As a disclaimer, please no recording. The presentation and the corresponding slides are copyrighted by Robson Forensic and may not be recorded, copied, distributed, or otherwise used without authorization. That said, if you have any questions throughout the presentation, you can submit them via the Q&A button at the bottom of your Zoom window, or you can email them to us at inquiries@robsonforensic.com. So for today, Jeff Tedder will be presenting. There are a number of hazards associated with concrete pumping. Hose whipping incidents are one of them. If you have questions about other concrete pumping related matters other than hose whipping, feel free to throw those in the Q&A section. And Jeff, I'll turn it over to you.
Okay. So we'll start off a little bit about myself. I am a forensic civil engineer with Robson Forensic, obviously. Been with the firm for roughly 2 years. I'm also a licensed professional engineer in 16 states. My focus is in construction safety, which is my professional background. So spent 17 plus years managing construction projects, mainly large water, wastewater treatment plant projects for self-performing general contractors. So I've built everything from $4.5 million projects to $300 million projects. Managed or supervised up to 1,000 concrete pours. It's a pretty decent estimate. And of those, about 300,000 cubic yards of concrete. Most of that was pumped. Quite a few of those jobs served the roles of either pour supervisor or site supervisor. So what we cover today, do a real basic overview of what concrete is, what the pumping mechanics are. We'll do a review of equipment basics, how a concrete pump works, then anatomy of a hose whip, common causes of hose whipping incidents, responsibilities of the concrete placement team, which is important. I think that's a common theme through these incidents that I'd like to spend a little bit of time focusing on that. And then helpful information for the expert that's helping you investigate the case. Before we kick that off, I'm going to show you a video, a little background on this video before I play it. American Concrete Pumping Association, ACPA, they're the standard organization for concrete pumping in the United States. They certify concrete pumpers. They're kind of the authority on all things concrete pumping. They set up this example concrete hose whipping incident. This is a controlled environment, one of their member organizations. Important to note that no one was injured in this video, but I'm going to go ahead and play this so you guys get an idea of what a hose whipping incident looks like. All right, so I'm going to move forward. We'll roll that one more time. That was accidental, but so as you note in the video here, pretty violent reaction. It happens almost instantaneously. One of the things that I'll point out while we're here, one of the most dangerous times during a pumping operation is at the beginning when you're priming out the pump. This is kind of what you want the area to look like. Nobody should be anywhere near the end hose when you're priming out. The other thing I want to point out here, and there's a diagram later on in the slideshow from ACPA, what we define as the hose whip area. Hose end hose is 10 feet to 4 meters, so between 10 feet and 13 feet, depending on the manufacturer. And that hose whip area where you want to keep people out of to keep them safe is that length of the end hose would be your radius. So think about a circle. If it's a 10-foot hose, you want people to stay 10 feet outside of where that hose is hanging, during prime out. And nobody that's unnecessarily needs to be there during placement. Those people also need to be kept out of that danger area. So what is concrete? You guys are familiar with concrete. You walk on it on the sidewalks. Your house's foundation is quite possibly concrete. You drive across concrete bridges. When you look at it, in general, it's got a fairly consistent finish. You can't see the aggregate. It'd be easy to assume that it was a homogeneous mixture. It's not. It's a non-homogeneous mixture of coarse aggregates. So think stone, rock, fine aggregates, sand, cement, and water. The air is naturally occurring when you mix the mix, and concrete can also come with various admixtures. A couple that are important here when we're talking about concrete pumping would be a high range water reducer or a retarder. Both of those admixtures prolong the life of the concrete, delays the setup, and improves pumpability in general. Admixtures are generally used on larger projects. Residential homes, you'll probably not see admixtures in those mixes. But the cement and water combined accounts for about 25 to 35% of the volume of the concrete. They're the active ingredients. So when the water hits the cement undergoes a process called hydration. It's a chemical reaction. And that reaction is what causes the concrete to gain its strength and harden. As you're pumping, the consistency of concrete is going to be somewhere between peanut butter and soft serve ice cream. The old guys in the industry refer to concrete as mud. I find that to be kind of a difficult terminology to use because there's such a variance in what mud can be considered. But in general, if it's too wet, the aggregate's going to separate and cause problems where you'll create rock pockets, which can create a plug. Or if it's too thick, the concrete pump's not going to have the power, the energy to push the concrete. These are just a couple pictures. So these are cut sections out of a concrete core, so you kind of get an idea of what the aggregate would look like. And then this, I think, is a helpful graph here. This is typical strength gain for concrete. So this is 28 days is the standard measure for concrete strengths. For 4,000 psi concrete, you're talking about the strength at 28 days. And as you can see here, the vast majority of that strength is gained up front in the first 7 days. Concrete will maintain its workability in general for 2 to 3 hours. So once the water hits it at the batch plant, you're on the clock. If you wait too long, it's going to be unsafe to pump. Pump concrete mechanics. Like I said, the consistency of the concrete is important. If it's too wet, you risk the potential that the concrete will segregate. If it's too thick, the pump's not going to push it. The diagram below gives you an example of the velocity profile of concrete as it moves through the walls of the concrete piping system. There's friction that acts between the concrete and the walls of the pipe. As you move closer to the walls of the pipe, that friction is greatest and it creates a drag. So it's important. I mentioned when it's too wet, the aggregates can settle out. As a large aggregate settles out, it's more likely to the friction between the aggregate and the wall of the pipe is more likely to cause a plug condition because the friction is going to be greater because particle size is greater. Ease of flow is dependent on what we refer to as the water cement ratio. That's essentially just the amount of water that's been added to the mix. Let's see. Priming. Priming's super important. Think of priming as lubrication. And that's the step that should be taken before you put that system into operation for the first time that day. So the operator shows up, he gets it set up prior to feeding concrete to the system for the first time. He should be using some kind of priming agent. Oftentimes we'll use a mason's grout, which is nothing more than Portland cement, sand, and water. And that's just an easier, thinner mixture, easier for the pump to push, and it coats the inside walls of the piping well. So you reduce some of that friction between the concrete and the walls of the pipe. Pumping equipment. So there's lots of types of pumping equipment. They fall under 3 general types. In the top left corner is a trailer pump. We're really not going to get into those at all today. But the hose whipping incident, the hazard of a hose whipping incident, is similar in the use of that type of equipment. And then you've got the truck mounted boom operated concrete pump, which is the middle photograph on the left. That's where we're going to spend most of our focus. The photograph below is a placement boom. So essentially it's the boom from the truck removed and put into place. There's no pump associated with it. You'd have to use a secondary pump, either the trailer pump or a truck mounted boom pump to supply the energy to place the concrete. So in general, concrete truck backs up. On the back end of the truck here is what we refer to as the hopper. That's this gray thing. That's where the truck disposes of concrete, or not disposes of concrete, but fills the pump truck with concrete so that can be distributed to where the concrete finishers are placing the concrete. From the hopper, it goes to a concrete pump. The concrete pump's very simple. It's just a 2-cylinder pump. It's hydraulically operated. As the hydraulic piston pulls away from the hopper, you're pulling concrete into this concrete cylinder. The other cylinder works in tandem with it. So as this concrete cylinder is filling with concrete, the other one's pushing concrete into the system piping, which runs the boom, comes through the end hose here, and is placed by the placement crew. So in this photograph over here in the bottom right hand corner, you see the placement crew at the end hose. Typically, you're going to see anywhere from 3 to half a dozen guys in that end hose movement area. And that's typical during a placement. You've got a guy, we call him the hose man, that's actually got possession of the end hose that is directing the operator and moving the hose. You'll have guys that have rakes and shovels that are doing fine tuning, moving concrete from one place to the other. You'll have a guy checking grade, and then you might have a couple guys with vibrators. The vibrators are used to consolidate the concrete, make sure there are no voids as the concrete's being placed. Typically, the operator is going to be somewhere close to the placement crew. Oftentimes, he's not going to be in a position where he can also monitor the hopper. That's important, and we'll get into what creates a hose whipping incident here in just a minute, but it's vitally important that we maintain the level of concrete in this hopper. If you fail to do that, the concrete drops below the top of this concrete cylinder, the concrete pump cylinder, you'll introduce air into the system. And air, as we'll see in a minute, is one of the main ingredients to creating a hose whipping incident. So it's important that we have somebody back there at the hopper, and it's important that you understand that the operator's primary focus is to watch the guys at the end hose and make sure they're safe. So we've got to have somebody else stationed in the back at the hopper. The guys that are driving the trucks, the mixer trucks, the delivery drivers, they're trained to monitor the concrete in the hopper, and they should be trained to notify the pump operator of a condition if air is introduced. And they should be trained to push the emergency stop button to make sure a whipping condition is not created. So moving forward, anatomy of a hose whip. There are three necessary conditions. Air must be in the delivery system. There's got to be something pushing the air, and there has to be a restriction. So air is a gas. It's compressible. Concrete is I would call it like a suspension of solids in a liquid. It's not compressible. So as the pump strokes, continues to push concrete behind air after it's been introduced into the system. If there's a blockage in front of the air will compress. As it compresses, the pressure builds, which leads to, as we saw in the video, a violent explosion of gas. The next slide, I'll go ahead and go to the next slide. So this is good visual representation from American Concrete Pumping Association, one of their documents. And what this is showing is just kind of the relative pressure in the line of an air pocket as it's been introduced, and kind of the compression of that air. So at the top there, you see 800 psi. So at 800 psi, that air pocket's 2.5 inches long. So as you start to move towards the end hose, that air is going to expand, as the restriction is removed. So concrete pump trucks generally will operate at a pressure of 1,000 psi is pretty standard. Big trucks have the capacity to pump up to 2,000 psi, which is a pretty extreme pressure. When you have a plugged condition, or a blocked condition, the concrete pump is going to continue to pump if you don't stop it until that restriction at the end of the line is freed. As this picture shows, that air pocket will compress. Once the restriction's relieved, then the air expands at a very rapid, almost instantaneous rate. And as you see here at the bottom, that same 2.5 inch pocket of air becomes 133.25 inches long as it leaves the end hose. Common causes of hose whipping incidents. Air has to be introduced in the system. We talked about the hopper and how important it is there. That's one way air's added to the system. Another common way that air is added to the system is through the end hose. So when you're pumping concrete, the boom is extended out. The end hose is hanging vertically. If you stop the concrete pumping for any reason for a short period of time, the concrete that's in the end hose, when you stop the pump, will fall out under gravity. A portion of that may be retained in the end of the end hose. The concrete that slid out, that was in front of the plug that's now been created, that volume is now filled with air. Okay, so that plug remains in the end hose. As you go to start repumping, concrete starts to move forward. You compress the air, it pressurizes, and it explodes. Those are two of the common. The concrete mix might not be suitable for pumping. I talked about that a little bit. The mix consistency may be wrong, too wet, too dry. The fine aggregate's not properly graded. Coarse aggregate's too porous. So what happens there? If the batch plant has not properly maintained their stock of aggregates and kept it moist, when that stone's added to the concrete mix, it'll suck up the water that you're depending on being part of the water cement ratio. And you end up having too dry of a mix, too lean of a mix, we would call it. Or the concrete is aged out, so you've waited too long. The batch plant batched the concrete 2 hours ago. It shows up on site. You're 2.5 hours in before you pump the concrete, and it's just hardened to the point where it's no longer pumpable. And there are other things here that are causes of delays. Another one, maintenance of the equipment. Pipe sections on the boom are roughly 10 feet long. They're connected by couplings. Those couplings have gaskets. One of the big problems is that if you don't maintain those gaskets, they rip, they tear. You can either lose water as you're pumping the concrete, which can be a problem, obviously, or you can introduce air into the system that way. Who's responsible? ASME B 30.27. In 2014, they updated the standard. This is kind of the standard in the industry for concrete pumping. So this is everything you need to know about concrete pumping and the way things should be done are in this document. And it outlines the responsibilities of different parties on a concrete pour. Prior to 2014, when this was issued, this whole responsibility matrix, if you will, was not well understood, still not really well understood. There's a general misconception that you hire a pumping contractor, the pump operator shows up on site and he's responsible for everything. That's just not the case. There's responsibilities across the board. Obviously the operator's primary focus is the safe operation of the equipment, and he's responsible for making sure the people within the danger zones of the equipment remain safe. So those are his primary responsibilities. He needs to operate the truck within the manufacturer's requirements, within industry standards. He's got to make sure people are safe. Note at the bottom, the actual organizational structure of projects differs widely, even on the projects that I've been on, where the general contractor may perform portions of the work and he subcontracts out, say, the placement of the concrete. to one subcontractor. So when I say placement, that's actually, formwork's been installed, reinforcements installed by the general contractor. He brings in somebody to actually place the concrete into the formwork. He may have a second subcontractor that does the actual finishing. So the contractor that makes it smooth and pretty. There are countless ways that a project can be organized. So it's important to consider that as we evaluate the responsibilities of the individual parties on the specific project and at hand. So information helpful to an investigation. I've got a lot of bullets here, but just to kind of summarize, it's important that we know first that the concrete mix that was proposed for the project was pumpable. So we'd like to see the design mix that the engineer put together to review it to make sure it's pumpable. The next step would be to look at the concrete that was actually provided by the mix by the batch plant. Did it meet the engineer's design requirements? So any kind of QC information we can get, batch tickets. They've got to maintain records for the aggregates they store on site. They've got to tell you on the batch ticket where the materials came from, the sand, the aggregate, that kind of stuff. Maintenance records for the truck itself. You want to make sure the manufacturer, not the manufacturer, but the operator of that piece of equipment, the pump company, has been properly maintaining his equipment. Any kind of records and certifications of the pump operator. The owner's manual for the piece of equipment, the specific piece of equipment, is important. A lot of what we're talking about that's covered in ASME B30.27 or in OSHA or ACPA is more clearly defined for that specific piece of equipment in the owner's manual. And it looks like I've run over a little bit, so I'm going to flip over to questions at this point.
Thank you so much for that, Jeff. A couple questions. So in terms of assessing the quality of the mix, can that really be done if it's been a number of years since the incident occurred? And, how would you go about that?
Sure. So, primary documents there that we want to see are the batch tickets from the batch plant. So they'll give you the relative volumes of each of the constituents that were added. And then the batch plant, like I said, should be maintaining records on the cement, who supplied the cement, who supplied the different aggregates, and they should have maintenance records for the constituents, so the aggregate and stuff like that.
Fair enough. And now, so similar, what other types of incidents, aside from hose whipping incidents, are there with these pump trucks?
Yeah, so the number one cause of fatalities with with concrete pump trucks operators is incidental contact with overhead power lines. So we've got experts that can address that, electricians, electrical engineers that can address that type of hazard, ground conditions, where a concrete pump truck was set up improperly based on poor ground conditions. And as the boom extends out, the concrete pump could collapse. We see a fair number of those incidents. Another common incident is when the operator is injured working on the piece of equipment. So say at the end of the day, as he's doing cleanup wash down of that piece of equipment, he comes in contact with a moving piece of equipment that's under under operation, and it crushes him.
Not a great way to end your day.
No.
Well, aside from that, we don't have any other questions submitted. For those of you in attendance, if you have any follow-up questions, if you have a case-related question, please submit that to us via inquiries@robsonforensic.com. Oh, we did just get one more question from Matthew asking how many operators are typical.
One is typical. There are states that require an oiler, based on union bylaws, similar to a crane. So, in areas where the union requirements require it, you may have two people in that truck, one operator and one assistant, which we'd refer to as an oiler.
Right. Well, that will wrap it up for today. Again, thank you everybody for coming. Thank you, Jeff, for giving this presentation, and we hope to see you all at the next webinar.
All right, thank you.